Thanks a lot for coming to our session. I'm Vivek Sharathi. I'm an architect in our storage division. What we're going to see in this session is learn about what is the advantage of using Intel's hardware with vSAN's architecture. We're going to focus more on the storage aspect of things, given vSAN is a storage solution that you're deploying. You're going to see how does CPU improves your performance, what are the key things that you need to be looking at it, and how does the network play a part in this? How does vSAN architecture work? How does the different ingredients that Intel provides fit in the architecture? Then we are going to go right into customer case studies, hear directly from the customers on how they are using Intel technology in their platform to build a vSAN architecture and see the benefits from them and learn why have they used the technologies that they are using today in their data center and how it's improving their overall infrastructure. I think it's going to be a fun session. Strap onto your seatbelts.
It was impossible until we invented it. It couldn't be built until we built it. It couldn't scale until now. Intel Fab 11X in Rio Rancho, the epicenter of Optane technology. Intel's revolutionary memory and storage innovation, built with a groundbreaking combination of endurance, consistent high performance, and low latency, designed to bring new and unforeseen computing possibilities to a variety of markets. And it all starts here. Intel, redefining impossible with Optane technology.
Now, Optin is based on the 3D crosspoint technology, and it is a transistor-less design, right? What transistor-less design means from an SSD perspective is your ones and zeros are basically done on a bit level. The performance, the endurance, and the various characteristics that you look at from an SSD perspective or from a storage perspective in general is way more improved than what you would see in NAND. There's going to be a big shift in the storage market. If you look at the NAND technology, the reads and write operations are done on pages. So every time you do a new read or a new write operation that goes in, it's done on a page level. Once the read and write operations are done, the page ends up getting stale, and you need to move it to a different location inside the SSD so that you can start writing in new write operations that's coming in. Before you write something new onto the SSD in the page where you had the copied data, you need to erase it. What this concept is called in the SSD technology is called garbage collection. This garbage collection ends up providing a lot of latency delays to the application that's sitting in the top, because the whole SSD is waiting for that erase operation to complete before you can start writing in something new, and the data is waiting for that operation to finish so that the new data can start coming in. And this ends up getting translated to the application that's sitting on top in your data center. Optane technology, like I had mentioned, is based on ones and zeros that is written on bit level. So you don't have this whole concept of, I need to wait for the page to be erased before I can start writing in new data. It's much different and it's much more efficient. What I did here was a basic 4-node vSAN cluster. So you have 4 servers. Each node has a couple of CPUs in them. You have network card connected to them for network traffic, and you have memory and the SSDs, where you have the caching to your device in blue and the capacity SSDs in black. So what impact does hardware make in this? Let's first focus on the CPUs. When you design a vSAN cluster and when you're trying to choose, hey, what CPU do I need to get the best out of my vSAN? There are 2 key things that you need to be looking at, right? One is the number of cores and the frequency of the CPU that you're using. The more number of cores that you have in the CPU, the more number of VMs that you can pack inside your vSAN cluster in that particular node, which helps you from an overall TCO perspective and helps you save quite a bit on the infrastructure cost that you would be spending. Frequency is directly proportional to how your IOPS performance is going to be. You can have the best storage devices in this box, but if you don't have the right CPU frequency, you're not going to get the maximum out of the storage that's present in that box. Choosing the right combination to support your infrastructure is key in choosing the CPUs. If you end up choosing a lower core based CPU, over time your infrastructure is going to grow. You want to pack in more VMs as part of the cluster. If you don't have the right frequency, then you're basically going to be underperforming from an IOPS perspective. The next thing is the networking. The vSAN traffic goes from one node to another node through the network. Having the right network is the key to make sure that you're able to support critical apps as part of the infrastructure. When I started building, the vSAN architecture, a lot of customers were using 1 gig or a 10 gig network as part of their deployments, right? But given the amount of data that's getting processed in vSAN and how fast the data needs to be transferred between one node to another node, having the right network and making it future ready is very important, right? So start from 25 gig, understand what is your requirement. We have seen a lot of customers, deploying 100 gig. That's forward thinking, right? Where you know that your requirements are going to be high. Keep an eye out for that. Choose the right networking that's needed and choose the right CPUs. The other thing is the storage part. To have the best performance that's coming out of the vSAN infrastructure that you're building, you need to be very careful in the SSDs that you choose, whether it's the caching tier device or the capacity tier device. Each of the SSD that you choose plays a part, and what kind of characteristics should you be looking at to get the best out of the vSAN from an SSD perspective, right? So let's look at the next one. So look at it from a VM level. The VM is issuing a write operation. It says, hey, I need to write this particular data. I'm giving you that data. Go ahead and do your work. So the data starts coming in from the VM. It goes through your vSAN software. It ends up landing on your caching tier device. So every write operation that happens on the VMs first ends up landing in your caching tier device. The key thing for you to understand here is, given every write operation ends up in your cache tier is 100% write buffer. So all the data ends up landing here. So once this caching tier starts filling up, around 30%, that data ends up getting destaged to your capacity tier device. So you have data that's getting from here and ends up landing in your capacity tier device. The key thing that you need to be understanding is, once the data has resided in your capacity tier device, all the read requests that's coming from the VM, right? If your VM says that, hey, I need to read some data that I've written, can you send it to me? Then that data is getting serviced by your capacity tier device. So key thing is, the read operations are serviced by my capacity. My write that's coming in is serviced by my caching tier device. So all my write operations ends up landing here, and it ends up acting as a 100% write buffer. The next key thing that you need to be looking at is a scenario where you see that, hey, I've written a data, but I need to read that data as soon as I write. You see this very common in number of applications where as soon as you write, you want to read. That particular data is getting serviced by your caching tier device. The reason is, it does not end up waiting for the data to get destaged before it serves the reads. If there's a write request that's coming in, it figures out, hey, I still have the data in my caching tier device. Let me just serve it out from this particular place. Let's call this as hot read. So any hot read that's coming in is getting serviced by my caching tier device. Key characteristics: one is caching tier device is 100% write buffer. The read operations are serviced by my capacity tier device. And if there's a hot read that's coming in, then it is getting serviced by my caching tier device. Now, the 4 key characteristics when you're choosing a caching tier device in vSAN is: 1, predictable I/O performance. Very important. Make sure the I/O performance is predictable over a long period of time. The second key characteristic that you need to be looking at is the endurance. Like I had mentioned, in vSAN, your cache tier device is 100% write buffer. You need to have a device that has extremely good endurance so that you don't wear out the device. The third key characteristic that you need to be looking at is low latency. For the application that's running in the VM, and for it to process the operations as soon as possible, having a device that sits here with low latency is very important. So you can process the data very quickly over a short period of time. The fourth key characteristic that you need to be looking at is higher IOPS or throughput. The more throughput you have or the more IOPS you have, the more data that you can process over a period of time. So make sure that when you're choosing your caching tier device, these four characteristics that I mentioned is front and center of you deciding the type of device that you want to use there. What I wanted to do here was to give you a perspective of how does an Optane SSD fit in a caching tier device in a vSAN. What are the key characteristics that Optane SSDs are able to solve that satisfies the four criteria that I had mentioned when choosing a device for your vSAN. If you look at Optane SSDs and some of the key characteristics that Optane SSDs provides on its own, one is responsive under load. No matter how much of write pressure that you do, the performance ends up staying stable over a long period of time. That's pretty impressive. Responsive under load directly correlates to the predictable I/O performance that you're looking at. Next one, endurance. Comparing an Optane SSD to a NAND, you're looking at endurance for Optane SSD is up to 60 drive writes per day. Now compare that to your NAND SSDs. You have NAND SSDs that are around 3 drive writes per day. You're comparing apples to oranges. So Optane SSD ends up satisfying criteria number 2 that we're looking at. Now let's look at the latency and the higher IOPS characteristic that we're looking at when we are trying to design a cache tier device. Now Optane SSDs provides you predictable performance over a long period of time at an extremely low latency and a very high IOPS or throughput compared to what you have in the NAND. You're talking about 10 microseconds with 500,000 IOPS that's getting serviced by your Optane SSDs, compared to NAND, which is way less than that, right? So from an IOPS and from a latency perspective, Optane SSD is a much better choice compared to what you would see in the NAND space, right? So predictable, faster service, your low latency is taken care, and the breakthrough performance takes care of both the low latency and the higher IOPS that we are looking at. So Optane fits into every segment that you're looking at in a vSAN cluster as part of your caching tier device. One of the biggest advantages from a customer perspective is the ability for them to get the performance that a device like Optane SSD offers in a vSAN cluster. So the vSAN software is optimized to make sure that you get the best performance when you have an Optane SSD in the caching tier device. Now you have a software that's optimized to get the best performance out of vSAN, and that basically translates to better performance for the applications that are sitting in your VMs. One of the questions that comes up often is an understanding of how mature is the ecosystem with Optane SSDs? How many OEMs are supporting it? Do we have ready nodes that has Optane SSDs as part of the deployment? For you to get a better understanding of this, if you go to VMware's VCG, or the place where they list all vSAN certified ready nodes, what you would see is around 140 ready nodes from different OEMs, tier 1, tier 2 OEMs who support vSAN as part of their offering. The reason is the customers believe it, the OEMs believe it, and they have invested a large amount of time and effort to get this ecosystem up and running. I was having a conversation with a Fortune 100 customer who was asking me about, hey, what verticals do you see Optane SSDs and vSAN being deployed? And the answer is pretty simple. Customers in every vertical have deployed vSAN with Optane SSDs in the production environment, whether it's FSI, healthcare, or manufacturing. The ecosystem has adopted it, and they see the benefit of it. Just to give you an example, I was speaking with one of an FSI customer recently, and they were mentioning to me that one of the main reasons why they are using Optane SSDs as part of their deployment is to support applications where latency is critical. They don't want apps to slow down that would affect the financial transaction that the bank is trying to do. And same example in the healthcare space. When you have mission critical applications running in the hospital, you want to have the best hardware supporting it, so that if a doctor or a nurse clicks a particular application to see the patient's record, it comes up to them as soon as they click it. They don't need to wait for it to load and do the whole process. And vSAN being heterogeneous, you see customers using it in multiple different scenarios. It's all across the spectrum, and there's been a great adoption for this. We have seen customers use it as a core storage engine powering their large data centers. You're talking about petabytes of data getting deployed with vSAN and Optane SSDs as part of the caching tier. And you also have customers who use vSAN and Optane SSDs as part of their remote office or a branch office deployment. And the benefits that they see across different places of deployment is great, and it provides the value that the customers need. It solves the problem that they're trying to solve at either the edge use case scenarios or at the core data center where they have large amount of data being processed. Different use cases, different ways of customer deploying it, and different verticals of customers deploying it. So something that you need to look at when you're trying to figure out, okay, what is my use case and how does it fit in? Optane SSDs as a cache tier device in vSAN is a great fit for you. Now, Optane SSDs being offered as part of vSAN ready nodes, and you have appliances from VxRail, HPE, and Lenovo. What you have seen is the ease of deployment for customers. The customers understand, yep, I have an awesome performance that's coming out. I save a lot of money because I'm able to consolidate. And they also see a lot of benefits on day-to-day operations. I'm going to migrate VMs, or I'm going to migrate data from one storage to another, and Optane SSDs helps me in that. To add on top of that is the ease of deployment. Given it's all part of the ready nodes or the VxRail platform or the HPE is offering or Lenovo's offering, you can have it as part of your data center in no time, right? And that helps you quite a bit. If I look at how customers are using it and some of the key benefits that they're seeing, I would split that into 3 different pillars. The first thing is performance. What the customers have seen is a huge performance improvement in the applications that they're running. That's one. That's the performance pillar that I'm talking about. The next pillar is around TCO, the total cost of ownership customers see. If customers were using 6 servers previously in a vSAN infrastructure and they had a particular SLA target that they wanted to achieve, and they were able to have 100 VMs able to hit that particular SLA in those 6 nodes, what Optane did was for them to consolidate those 100 VMs to 4 servers. So you're going from 6 servers to 4 servers, and you're able to hit the same SLA that you were targeting for. The third pillar is around day-to-day operations. How much of time are they saving when they're trying to migrate a VM from an external storage to vSAN? Or what happens when VMs in the vSAN is migrated from one node to another? So 3 key pillars. One is performance. The other one is around the total cost of ownership. And the third one is around day-to-day operation. All very important aspects that you need to be looking at when you're trying to deploy a vSAN architecture. Total cost of ownership, or TCO, is a very critical aspect when you're trying to design a data center. You want to make sure that you stay within your operational expense as well as the CapEx, the initial investment that you're doing. Optane SSDs brings in great value from a TCO aspect and from a performance aspect as well. To hear about the TCO benefit that Optane has in vSAN, let's hear it directly from Ironbow. Ironbow has had a lot of success in able to manage the right TCO benefits for their deployment using Optane SSDs and make sure that they're not compromising on the performance.
Hi, my name is Troy Massey. I work for Ironbow Technologies. Ironbow is everything from audio-visual to data center to networking. A large focus of our footprint is DoD. 75% of our business is DoD, but we also have a civilian, commercial, and healthcare unit. I'm the Director of Enterprise Engagements. So about 2 years ago, virtualization was really hot, VDI was really hot. So I said, we're going to create a go-to system that is Ironbow's what we hang our hat on, that's a design for virtualization, for virtual desktop. Along with that, VMware exploded into a Virtual Cloud Foundation's product, which is a glue together of their best products. And it really fit the bill for what we were trying to do as a system. At the same time that was happening, Dell came out with VxRail. And VxRail is a hyper-converged product that is just lightning fast, big red easy button, boom, you've got a data center in a snap of a finger. So combine those together with our secret sauce, and we came up with Iron Target. So what is Iron Target? This is that big red easy button to get a company over to a cloud that's very non-threatening. Speed of deployment is a few weeks versus months and months and months. Performance, there's price point, and there's cloud adoption. It's also built into the system with CoopDR, the ability to fail over to another site. Everybody has had a quest for a continuity of operations disaster recovery plan for decades. It's plug and play with IronTarget. So inside of IronTarget is Intel's Optane technology, their Xeon processors, all that makes for a super fast gateway to the cloud. But today's challenges are a little different. Virtual desktop infrastructure, VDI, is one of those cases that, especially now during COVID, everybody has to work from home. The world changed a lot this year. If you were to think about yesterday being 9 months ago, the main concern of a data center team was cloud adoption. It was #1 priority on their list. Now, today, everybody's trying to figure out how to do business from home. So that remote architecture is very, very important. The problem that we see is that a lot of companies don't think about tomorrow. What happens when people go back to the office, when they go back to work? That solution just doesn't matter anymore. IronTarget is future-proof. So it is there to answer yesterday's problem of how do we do easy cloud adoption? It's the big red easy button to the cloud. It's there now for how do we do remote VDI? And it's there tomorrow for when people start going back to work, it's still the on-prem cloud. It's still the link to a public cloud. So it's future-proof. IronTarget, built by design, has VDI available. We can make a virtual desktop infrastructure workload from the data center to the home, and you can just work like you were at your office. One of the things that always gets left behind, and people tend to look the other way a little bit in fear, legacy systems. They were built 10 years ago, and the hardware that they're on is no longer even built anymore. So built into IronTarget is technology around Pivotal, which is a VMware product. We can actually decouple those legacy applications from their legacy hardware and make them virtual to go onto IronTarget. Very popular cure that few have found the answer to. So vSAN is virtual storage. It is a product within VMware Cloud Foundation. And so what it allows us to do is all the storage within IronTarget, we're not just limited to that storage. We can virtualize storage from old hardware. We can pull that storage into IronTarget to be used as a larger data center. VMware Cloud Foundation is a glue together of their best products. vSAN is in there, vSphere is in there, vRealize, SDDC Manager, and one of the most important ones is NSX. Basically all combined, it creates an on-prem cloud that allows you to click and drag from that old data center and to a public cloud, or just sit on IronTarget. So Intel Optane technology benefits us because it's simply the fastest storage out there, and it enhances the performance level to a point where our competition can't measure up to. So we have low and slow, cheap and deep storage from vSAN, and then we have the Optane layer of storage, which is super fast performance. So when you need quick access to data, it's Optane. When you need something long-term storage, it goes to the rest of the glob vSAN creates. We chose Dell EMC, specifically VxRail, because it is the fastest performing hyper-converged platform out there. And within a matter of a day, you can deploy an entire data center. All of our customers every year have end-of-life, end-of-support servers that they need to do a tech refresh on. So our recommendation is we deploy VxRail in a small stack, and as time continues and they have new workloads, they go onto IronTarget. They have more end-of-life, end-of-support servers, they go on to IronTarget. So they scale up in a more cost-effective, more structured manner. Our friends, our partners over at Dell did an analysis for us, and it's actually lower cost to deploy an entire VxRail solution than it is to do a tech refresh on the storage area network. So total cost of ownership is astronomically a better value. Combine that with the performance of Intel, the software of VMware, and the secret sauce of IronTarget, and more importantly, that's all under the Dell umbrella, and it makes all of this magic happen. So Intel and Dell are the best of the best. When it comes to adoption of Optane, the performance metrics are amazing. The speed difference is just unquestionable, and it's just a win-win combination. So we're producing a very elegant solution to the customer.
I've talked to you about The importance of consistency in performance. Consistency in performance of vSAN basically translates to how well your applications in VM run over a long period of time. So let's hear it directly from Sujoya University to understand more about how they are using Optane SSDs in the infrastructure as part of their vSAN deployments, and the benefit that it provides to them with regards to the IOs and how stable the IOs have been in their applications and the total cost of ownership saving that they have.
成城大学の五十嵐和弘と申します。役割としては、大学の ICT を一手に担っているマネージャーの役割をしているんですけれども、プレイングマネージャーなので、仮想化だったりネットワークだったりセキュリティだったりいろんなことをやっています。で成城大学は、大体学生の規模が、6000人ぐらいで、教職員合わせて約7000人ぐらいの、ユーザーがいます。で彼らの使っている ICT を、陰ながら支えているっていうのが我々の部署の仕事になっていて、でうちのチームも、サポートから、システムの構築、運用、それから設計等全てを担っております。Optin導入の経緯ですけれども、成城大学では vSAN のかなり初期のバージョンから本番運用として使っておりました。で当時は、ハイブリッドの構成しかなかったので、SSD とマグネティックのディスクを使って、それぞれキャッシュとキャパシティという形で構成しております。でですね、更新の時期にあたってなんとかそれをオールフラッシュに持ってきたかったんですけれども、ただただ SSD をオールフラッシュにするのでは面白くないと。で私はVMware っていうコミュニティのジャパンのリーダーをやってるんですが、この VMware コミュニティですね、実はグローバルな組織であって、VMware とかで、みんなリーダーで集まってメンバー間で情報交換などをしています。その中で、Optin の存在を知りました。耐久性、パフォーマンス、レイテンシー全てにおいて優れたこの Optin を次の vSAN のシステムに組み込むことで、大変期待が持てるものが作れるんじゃないかなと期待して、ぜひですね採用したいと思って Optin を選択しました。375ギガの Optin SSD を、2枚各ノードに実装しました。でオールフラッシュの構成を組んだんですけれども、実際にデバイスのレイテンシーを取って比較してみると、前に入れていたハイブリッドのシステムとは本当に比較にならないほどの、圧巻的なレイテンシーを実現してくれました。ハイブリッドの方だともう 何百ミリセックのデバイスのレイテンシーがあったんですが、実際に Optin のシステムですとこれがマイクロセックという形でもう単位が全然違うんですね。今サービスのクラスターは6台6ノードで運用してますが、運用管理系のクラスターについては3ノードです。でこの3ノードの管理系のところはNANDの、キャッシュを使ってるんですけれども、こちらと比較しても Optin では、2桁マイクロセカンドで NAND SSD の方は数百マイクロセカンドぐらいのレイテンシーなので、最新のNANDのキャッシュを使ったシステムと比較してももう完全にレイテンシーという意味では、上回っています。Optin を入れてうちのチームが大きく変わった点なんですけれども、Optin の特性の耐久性ですね。多分これシステムを、実際5年6年使ったとしても、システムが壊れたとしても Optin だけは壊れない。我々安心していろんなところに出ていくことができるんですね。例えば今こうやってビデオシューティングしてますけれども、これも Optin のおかげで、安心して職場を離れてシステム管理者がずっと守りをしてなきゃいけないシステムではなく、壊れる心配がない。だから管理者も自由にいろいろなところに出ていっていろんな活動ができると。なので私は、大手を振ってコミュニティの活動に参加することもできていて、またそこで情報を得られて、すごくハッピーな、サイクルが生まれているんだと思ってます。vSAN のキャッシュはもともと600ギガまでが上限なのですが、本学が採用した375ギガの Optin SSD でも1クラス上のパフォーマンスが期待できます。ぜひですね、皆さんにこの圧倒的なパフォーマンス、それから低レイテンシーを体験してみてもらいたいと思ってます。
Intel IT's infrastructure is heterogeneous, which means you have multiple apps with different requirements running in a single storage system. They wanted to find a common solution where the storage application that they're running is being supported by a storage engine that is able to satisfy both from a performance aspect and provides them the ability to scale, and also support the day-to-day operations that they have, whether it's migrating VMs from different storage systems to vSAN or migrating VMs from one node to another node. What they saw was benefit across all of them. Optane SSDs and vSAN provided them the ability to do multiple applications and satisfy the heterogeneous requirements that they had. To learn more about this, let's hear from Intel IT on their story of how they have used Optane SSDs and vSAN.
Hello everybody, my name is Jos Kurian. My job title officially is a software architect. I'm part of the automation team. We automate Intel's memory factories. My team, shop floor controls, is responsible for keeping the factories running optimally around the clock. Everything that runs in the factory has very sophisticated processes, and our best-in-class systems make sure that all the tools, all those OHVs are working in harmony so that our factories perform better and better. Time is the essence of everything in semiconductor manufacturing. The more time you take in the manufacturing to process material, that means we are wasting money. So virtualization is also something that is in the charter of my team. Virtualization needs to be designed very carefully. In our case, we have a lot of web-based applications or APIs. We have data processors, we have file movement services. All of them demand high-performing CPUs and memories and SSDs. So it's a really heterogeneous workload. Once when we put virtualization into it, we are consolidating all of those servers into smaller number of hosts in the data center. That means we are reducing the fault domains. When it comes to day-to operations, it becomes very easy for us to manage and maintain these servers. With newer technologies, we will be able to swap out better performing components and scale to better performing infrastructure without impacting the workload. Our virtualized server use cases used to have 3 disk groups, all flash. That means we are using NAND disk in the cache tier as well as in the capacity tier. Our new design uses Optane in the cache tier, but not 3, just 2. The advantages here is that Optane is really better performing when it comes to write intensive use cases, and in an all flash vSAN implementation, all the writes happen at the cache tier. So Optane SSDs saving in the cache tier helps the workload tremendously. Another advantage is that when we have 2 disk groups, it's lesser disk groups to maintain, and we have a lower sized disk in the cache, but we are still able to see that performance benefit. This also means that we have more slots open in the server. If we want to add more capacity disks in the future, we can scale that server accordingly. We saw another day-to automation advantage when we converted this physical to virtual using VMware vCenter converter. We converted 5 physical servers of 1 terabyte, and it took only 4 hours compared to 4.5 hours, and we noticed 11% faster write transactions when we were doing it. This is a defect metrology analysis application. We compared it side by side between 2 factories, one using the NAND based implementation, the other one using Optane based implementation, and we spotted 14% faster performance for the application. That means we could get to know the defects and respond to them in a much faster way. So another use case wherein we found Optane helping us is the database server roles. We found that when we restore SQL Server databases, it is 2 times faster. This is also crucial when we do hot application maintenances. If you want to restore a SQL Server database, you really want to get the application back online as soon as possible, and you want the restoration process to be completed faster. Another area where the database server roles performed better is in the case of write-intensive queries. We find that write-intensive queries are performing 20% faster. This is very important in cases of cloud-based database instances. The database is performing better. That means the cloud infrastructure is really performing better. Another key use case that we have is the virtualized industrial PCs. We moved 2 virtual machines from our NAND-based implementation to Optane-based implementation, and immediately we could see throughput charts showing better results. That means we are not wasting any time in processing materials. Also, when we vMotioned these virtual machines from Optane based implementation to all NAND implementation, it took 9 minutes. When we moved it to the Optane based implementation, it took only 4 minutes. Another key aspect of day 2 operations wherein we see advantage of using Optane in cache is during our monthly patching. When we patched one virtual machine in an all NAND implementation, it took 1 hour. When we did the same in an Optane implementation, it took only 30 minutes. The important thing to note here is in the use cases that we implemented, it's supporting a very sophisticated manufacturing process in the factories. And if you have use cases where the use case is very demanding with respect to throughput, IOPS, latency, then this is a very good reference architecture for virtualized vSAN based implementations. Optane and vSAN, what we see is that it is better performing together.
Capital Online Data Services have been using Optane SSDs in vSAN. One of the key things that they wanted to solve as part of their vSAN infrastructure was the quality of service. Let's hear more from them on how they are using it as part of their vSAN infrastructure and how it's been able to solve some of the issues that they have been facing.
首都在线是国际化云计算服务提供商，在欧美、亚太等地区部署多个节点，服务于全球不同行业的用户。首都在线业务范围包括弹性计算、裸金属、私有云、出海业务等，致力于为各行业、企业级用户搭建高效、稳定和可靠的定制化专属上游方案，这也是首都在线的特点和优势。私有云是首都在线主营业务之一，覆盖游戏、视频、电商、教育、金融、医疗等各行各业。这些企业对数据的安全要求较高，核心数据放在独享的私有云，缺少资源独自管理、维护基础设施和底层服务。在虚拟机部署的应用对业务的高并发、海量数据访问、数据安全、业务实时性等要求较高。我们与 VMware 的深度合作，参加了 VCPP， 并采用 vSAN 等技术用于虚拟化存储管理，提升安全性、管理缓冲与存储模块，实现最佳存储性能。与此同时，我们发现客户在存储方面对数据安全、海量数据访问、业务实时性、业务扩展性、低成本方面有较高要求。奥腾固态板符合以上需求的特点，读写快、低延时、高安全性、耐用性、高容量、易扩展、高性价比等。于是我们使用奥腾固态板、至强处理器等英特尔产品来搭建 vSAN。未来首都在线将继续不断创新，也希望用到更多英特尔先进软硬件产品，为用户打造更多样化的高品质的云计算方案。
Thanks a lot for all the customers in joining me today to give you an understanding of how does Optane SSDs and Intel's technology fit in the vSAN and the benefits that they have seen. One thing that you clearly see is the different verticals that the customers have deployed this and the benefits that they are seeing, whether it's manufacturing, whether it's financial services, or whether it's educational institutions. And the other key thing is for you to understand that the deployment of Optane SSDs and Intel technologies with vSAN has been across the globe. So there's been a great momentum and customers are seeing the benefit of it and you have heard it directly from them. Thanks a lot for joining the presentation. I hope it was useful for you and hope to see you using Optane SSDs and Intel technologies as part of your vSAN deployment.